All right, the last video of the year. All right, so we're going to go from 31 to the end. We're going to skip one question. All right, so I to the third. Remember, if you can't remember these, change your calculator to A plus BI mode when you open it, and then put in I is I squared will come out to be -1. I cubed is equal to -I, right? And then I to the fourth would be -1. All right, so you have that cycle. So you could just put them on your calculator. So you could take this, and so this becomes negative xi minus 3y, right? And since it's squared, we have to do a FOIL with both of these, with two binomials, right? So this becomes 4x squared I squared, the first terms. The first outer is plus 6xyi. Now the inner, that's a negative. Oh no, negative times a negative is a positive. That's a positive. And then a negative times a negative is another positive. 6xy xyi. And then the last is -3y times -3y, which is 9y squared. All right, so I squared is equal to -1. So this becomes 4x squared times -1. 6 and 6 is 12xyi. And plus 9y squared. So you have to multiply this by -1. So it becomes -4x squared plus 12xyi plus 9y squared. All right, so that's 31. 32. A survey was given to 1,250 students selected in high school at the end of their junior year. The survey offered 4 post-graduation options: 2-year college, 4-year college, military, or work. Of the 1,250 that responded, 478 choose a 4-year college. State one possible conclusion that can be made about the population of the high school juniors, right? So we could figure out a percent. The most obvious one is 475 choose a 4-year college, right? So we could do the part out of the whole, which is 1,250. Multiply it by 100, and we get 38%, right? Choose a 4-year college, right? Also, we can take 100, subtract 38%, and we get 62%. So one conclusion we can come to is 38% of the students will attend college. Will attend a 4-year college. Because they also had 2-year college in there also. A 4-year college, while 62% would choose a different option. All right. All right, so that's 32. 33, I didn't do any probability. I apologize. So I'm just going to skip. This one's a probability question. There's still plenty of points for you to do well without that one. So let's go to 34. Right, the first thing we have to do is isolate the radical sign. So we're going to take 2x is equal to 6 plus 2 radical x minus 1. And we're going to subtract 6 from both sides. I'm going to undo addition and subtraction first. All right, then we're gonna divide by 2. But remember, when we divide by 2 here, we have to divide everything by 2. So this becomes x minus 3 is equal to the square root of x minus 1. To get rid of a radical sign, we have to square it. So we're going to square both sides. So now I have x minus 3 times x minus 3 is equal to x minus 1. So we do the FOIL, right? We have x squared minus 3x minus 3x and plus 9 is equal to x minus 1. This becomes x squared minus 6x plus 9 is equal to x minus 1. You could square a binomial by multiplying them and double them, that's fine. Any way you do it, as long as you get to x squared minus 6x plus 9. And then we're going to subtract x, add 1, because it's a quadratic, and we have to solve it by making it equal to 0. So I have x squared minus 7x plus 10 is equal to 0. And this factors 2 negatives, right? Because a negative times a negative will give me positive 10, and a negative and a negative will give me 7. So this is 5, negative 5, and negative 2. Negative 5 and negative 2. Okay, so x is equal to 5, and x is equal to 2. Now we have to check both of these, so we have to go back to our original equation and plug these in. Right, so we're going to go right here, we're going to do 2 times 5 is equal to 6 plus, remember, radicals and fractions you have to check if it's an equation and you get values for x. Plus 2 times the square root of 5 minus 1. This becomes 10 is equal to 6 plus 2 times square root of 4. This becomes 10 is equal to 6 plus 2 times 2. All right, 10 is equal to 6 plus 4. 10 is equal to 10. All right, so this one is one of the roots, one of the solutions. And let's try negative 2. I'll just zoom out so I can see the equation. So I have 2 times negative 2 is equal to 6 plus 2 square root of negative 2 minus 1. All right. I'm sorry, this is positive 2. Positive 2 and positive 2. The heat's getting to me. Okay. So this is 4 is equal to 6 plus 2 radical 1. This is 4 is equal to 6 plus 2 times 1. 4 is equal to 8, which it's not equal, so we're going to reject this one. That's an extraneous root. All right, this root's extraneous. All right, we're up to 35. And make this full size again. During the summer, Adam saved $400 and Betty saved $3,500. Adam deposited his money in Bank A at an annual rate of 2.4% compounded monthly. Okay, Betty deposited her money in Bank B at a rate of 4% compounded quarterly. Okay, so the basic formula is the outcome is equal to the initial amount times 1 plus the rate raised to the t power, right, where t is in years. Okay, so for Adam, he has an initial rate of 4,000. He has 1 plus 0.024. And they want to know value is represented after T years. They want us just to write the equation, right? T years. But remember, his is compounded monthly. So we have to multiply this by 12, and we also have to divide the rate by 12. So if we do that, Adams, A of T, Adams is 4,000 times 1 plus 1.002 raised to the 12t power. Okay? Betty starts out with $3,500. 1 plus her rate is 0.04. But she's being compounded quarterly, right? So there's 4 of these, 4t, and I have to divide this by 4. Okay, so I have to divide the rate by 4. So hers is 3,500 times 1.01, right, raised to the 4t power, right? And we're going to change those to x's. So if you have those two equations, you got all the parts for part 1. Then it says use technology to determine the nearest tenth of a year, how long it will take for the two accounts to have the same amount of money, and justify your answer. So you go to the calculator. I'm going to try this calculator. Let's see if I can do it with this calculator. Y equals, I'm going to clear this out. I'm going to put in 4,000 times 1.002 raised to the 12x okay, 4,000 times 1.002 raised to the 12x, and Betty's is 1.0, let me put the rest in, 3,500, the initial amount, 1.01 raised to the 4x. Okay, now our window, we're talking in how many years, right? So in T years, so the years are going to start. So let's go to window and let's change these to, hopefully it'll happen within 10 years, right? So I'm going to put 0, 10, right? Increments of 1. But the amount of money is going to be a much higher than that. So I'm going to put, we could start from 3,000, right? Because we know 3,500 is the least amount in, right? 3,000, and let's clear this. It's going to be more than 4,000. If you want to put in 5,000 or 6,000, it really doesn't matter. 6,000, and we'll see what happens, right? And then we're going to put in. Let's put in increments of 500. So that would give us, so many on there. So if we graph that, hopefully we get 2 points that intersect, right? So we have intersecting points, right? So now we're going to do a second calc, right? And we're going to do intersection, right? The left bound is here. The right bound, I think you just have to hit it twice on a TI-84. And we get, intersection is 5 point, which is nowhere near what mine has. I don't know why. Let's try it on the other calculator. Let's see. Oh, I see why. Because I put the second one in wrong. All right, let's try it again. 3,500. 1 raised to, I must hit the divided by button right there, 4x. Okay, let's go graph. And we still have this intersection. So let's do second calc. intersection. What is this, a commercial? Are you guys kidding me? Oh. My left bound I'm gonna put here. My right bound I'm gonna move it up here. That's more like it, right? So it's 8.437 years for them to have the same amount of money. For the two accounts to have the same money, the intersecting points. All right, so let's go back and write that in. And then we have to write a little thing about it. So x is equal to 8.437, right? To the nearest tenth is 8.4 years, right? So the two graphs intersect where the two would be the same. Two functions are the same. At 8.4 years. All right, not too bad. So far, not too bad. All right, so the next one is a trig graph with no equation. There's no equation, so we have to draw it the best we can. So from what we know. On the graph below, draw at least one complete cycle for a sine graph passing through points 0, 2, and has an amplitude of 3 and a period of pi and a midline of 2. Well, the normal sine graph looks like this. It starts here through 0. It goes up to 1. It comes down here. Turns around here at 3 pi on that, right? That's your normal one, right? Now, it says that's one cycle, right? And then it goes in this direction like this. Right, that's the normal sine wave. It starts at 0 and goes, and we'll put that in the calculator in a second. All right. Now, it says it has, draw at least one complete circle that goes through 0, 2. So here's 0, 1, 2. So it has to go through this point, right? It has to have an amplitude of 3 and a period of pi. All right, and the midline is at y equals 2. So we have this dotted line at y equals 2. Okay, the period is pi. So from here, I'll draw this in red. From here to here, we have to make one complete cycle. Okay, so what we're going to do is it has an amplitude of 3, so it's going to go up to 3. 1, 2, 3. Right? So it goes up, and then it's going to come through 0, and then it's going to go down 1, 2, 3, and then it's going to come back up here. So it's this, that 2 gives horizontal compression. Okay? That's all you have to do is answer that in that, right? And if you want to go the other way, that's one cycle. Now it says, so if you wanted to write this as an equation, it's y is equal to, the amplitude comes first, sine, the period is 2x, right? That's the compression. And the horizontal shift to the midpoint is up 2. okay? So we can put both of those in our calculators and look at them. You can also continue this in the other direction, right? So it's going to go from here, it's going to go to here, to here, and then back here. So it's also going to go in this direction. I wish I would have drew it a little neater, but all right. So if you want to, put on your calculator, there's none there. But if you could make it from what's told to you, just remember you have to go to mode. Make sure your mode is in radians, right? Mine is in radians, right? Make sure your calculator is in radians. We're going to put in 3. Let's put in sine x first. Sine x. And let's put in 3, the amplitude. Oops. Let's put in the amplitude, which is 3, sine, the period, which is 2, x, right? And the vertical shift, it was shifted up 2. All right, and then let's go to our window. Right, I put them all in. This is negative pi divided by 2, 2 pi, and then the scale was, let me put them in so you know what I'm saying, right? So you put in this one, this is negative 2 divided by negative 2 pi, right? This one is positive 2 pi. Our increments on our graph is pi divided by 2. So in a second, pi divided by 2. So if you're given one with it, you could definitely do that. And then I did the height of the graph. The graph has 8 in the y direction. So if we graph these, you can see, right? You can see we graphed, it's off a little bit because these give you the numbers where yours gives you the pi. But it's the same thing. It's basically the same thing. All right. So where is it always increasing? Where is it always increasing is the second question. Well, it's always increasing from here to here. From here to here. Now, it's halfway between 0 and pi on 2, halfway between 0 and pi on negative over negative 2. So that's 1/4 pi. So it is increasing always from negative pi on 2 to, pi on 4, right? Right? From this point is pi on 4, negative. This point here is the x is pi over 4, right? To pi over 4. And that's all I want to say about it. And finally, a grand finale. 6 points, which I didn't think was a very difficult question, but, I know you all shuddered to think. First of all, the graph gives us part of it, right? Gives us a lot of information on what our scales should be. It also gives us a manufacturer's sweatshirt finds the profit cost fluctuating between the number of products created. Creating more products does not always increase the profits because it requires additional costs, such as building a larger facility or hiring more workers. The manufacturers determine the profit in thousands of dollars. So let's just make sure that everything we see, we have to add 1,000 to it. When we get a number, we have to add 1,000 to it. A function of the number of sweatshirts also in thousands. Okay, so it's given like this. So what I did was, it's from 0 to 9, the domain, right, over that interval. So on the x-axis, I need all the way up to 9. Okay, this is 30. Go 60, go 90, you can go more, 90, 90, 100, 120, okay? I did it, so I know I don't need more than that. In this direction, this is negative 30. Oh, maybe we don't need it because this is also negative 60. And this one here is negative 90. So we probably only have to go to positive 90. All right. So I'm going to use the other calculator because this one's closer to yours. So I'm going to make a table. X and Y. Right? I'm going to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Nice, easy peasy. So we're going to go to the calculator. Use this one. And Y equals, I got to clear this one. Y equals, I got to clear this one. All right, and I'm going to put in negative x cubed, negative x raised to the third, plus 11x squared, minus 7x, minus 69. Okay, so you put that in your calculator, and then we're going to go to window. We're going to change our window. Right, our window we're going to change in the x direction. It's actually from 0 to 9 we want, right? We want 0, we want 9, right? Oops. Scale of 1, that's good. And from here we want to go from negative 90 in the y direction to 90 as the max. Whoops. To 90. And that is in... The scale here is 30. Okay? So we graph this. I think this was a good graph. We graphed this. We could see kind of sweeps up and it goes to 3, somewhere between 3 and 4. It crosses the x-axis, right? And then it looks like somewhere around 7, a little more than 7, it turns around, comes back down. Okay, so the first job we have to do is we have to graph it. So let's graph it. Let's graph all these points. This was let's look at the table, right? So we're going to go second graph, which is the table, and you could see 0 is negative 69, 1 is negative 66, 2 is negative 47, 3 is negative 18, 4 is 15, so now it's crossed the, right? I said somewhere between 3 and 4 it's going to cross, and then 5, 6 is 69. It's going up, it's going up, it's going up, and then it starts coming down somewhere between 7 and 8, and there's 9. So we could fill out our table. Negative 69, negative 69, negative 66, negative 47, negative 18, 15, 49, 46, 69, 78, 67 is the turning points around there somewhere, and then 30. Okay, so we graph this, it looks like this. We have a point here, a point right about here, a point here, a point 3 right there. 4 is 15, so it's right in the middle there. 5 is out there. 6 is more. 7 is 69. Right, so 50, 16 is right about there. So we have a point there, there, and then it starts coming down, and it ends up at 30. Right, so this last one is 30. So you have this little curve here, comes up through here, turns around, and comes back down. Okay, and it ends at those two places. You know, on my graph it was like really stretched. All right, so the next one says On the given interval, write the coordinates of the maximum of P and round all values to the nearest integer, right? So that's what this question says, this next part. So I go back to my calculator, right? I'm gonna go to graph, and I'm gonna do a second calc. Second calc, which is part of trace, right? I want a maximum, and it asks me for boundaries. So I'm gonna get like over here, I'm gonna hit enter. Then once the right boundary, I'm gonna move it over here and hit enter. And I think you have to do an extra hit. You have to do an extra hit for the guess. All right, so we get 778. Let's write that down, 778. All right, so this was 778 is the max in that interval. And what does it mean, right? For 7,000 sweatshirts, the maximum profit would be $78,000. Okay, and then the second one says determine how many sweatshirts to the nearest whole sweatshirt the manufacturer would need to produce in order to make a profit. So where it turns from a negative on the y-axis to a positive. So we're looking for the x-intercept, right, a 0. We're looking for one of the zeros. So how do we get that? So we go back to the calculator, right? This calculator, right? Now we're gonna do a second calc again, and we want 0. And this one calls for left bound, so I'm gonna move it to the left over here by 3. And move it to the right, a little bit past where it is. And we have x is equal to 3.54884, okay? So let's put that on our sheet. X is equal to 3.54884. Now remember, then we got to multiply that by 1,000. So x is equal to 3.5. So we got to move this over. Ones, tens, hundreds. Right. That's 3,000, right? So we just multiplied it by 1,000. So it's 354 rounded to the nearest point, 9 sweatshirts. I just almost wrote a bad word. That's hilarious. The last one, sweatshirts. Sweatshirts to make a profit. All right, so that profit. All right, so that's the end of all the reviews. Good luck Monday. Don't forget, bring a calculator and a straight edge. We have some here. They'll be given out. If you don't, please borrow one if you can. Get it from your older brother or younger brother or sister. And, see if we can have enough, have everybody bring one instead of having to wait to give them out. All right, if you have any questions, email me, and I'll try to answer them. Have a great day. Bye.